Dear students, let's see how to sketch a curve. As shown in the example, you're required to sketch the curve, which is fx equals to x cubed minus 3x plus 2. So this is a cubic graph. So before you sketch, you need to work out the details of the graph. Okay, the first step would be to identify the y-intercept. Okay, so y-intercept for this question occurs at when x is 0, you equate x with 0 and you substitute into the equation fx, and you will reduce your y to 2. So the y-intercept is 0, 2. Next, you need to find the roots of this equation, meaning equating y to 0 or fx equals to 0. Okay, and you need to identify what is the first root. You can always use your calculator to identify the first root. And next, you're required to show the working to get the remaining roots. So you can use polynomial division, or as shown in this example, you can use the synthetic division. You divide the equation with 1. Okay, so because 1 is the root of this particular equation. And when you get a remainder of 0, then it's confirmed that the x cubed minus 3x plus 2 equals to x minus 1 multiplied by x squared plus x and minus 2. Okay, so based on this, then you can further factorize. You can use your calculator for the factorization purpose, and you will arrive to 3 different roots. So this particular function has 3 distinct roots, which are 1 and negative 2, and the root 1 is being repeated. Therefore, there are only 2 roots for the particular function. So the roots of this function are 1, 0 and negative 2, 0. In other words, these are also the x-intercepts of the function. So far we have found the y-intercept and the x-intercept, and the next step would be to find the stationary points and to determine the nature of these stationary points. The first step to define the stationary points is simply finding the derivative of the function. So this will be the derivative of the function, and then equate the derivative of the function with a 0, and then we solve, and we will get x as 1 and negative 1. So these two x values actually represent the x coordinate of the stationary points for this function. Okay, so based on this, you also need to find the y coordinates of the stationary point. So we will get 1, 0 and negative 1, 4 as our two stationary points for this particular function. Next, we need to continue to find the nature, and you're required to use the nature table to identify the nature of these 2 points. So you need to draw the nature table as shown in the earlier pages of your open learning. Okay, so you need to draw a nature table and show the values clearly, and based on this nature table, you will obtain a maximum and also a minimum turning point, where this summarizes that this particular function has got stationary points at negative 1, 4 and a minimum turning point at 1, 0 based on the nature table you obtain. Next step will be to check the behavior of this function, as in when x increases to be a higher positive value or a larger positive value or negative, what happens to the y. So you need to look at the function, and if you substitute x with a very large positive number or very large negative number, your y would approach positive infinity and negative infinity respectively. You will just keep on increasing. Okay. Next, we will check on how to sketch the graph. So when you want to sketch the graph, you need to identify and label clearly your x-intercepts, which were negative 2 and 1 based on your calculation. And then your maximum turning point was negative 1, 4, and minimum is 1, 0. Once you get all these points, you can identify the shape of the graph. So the shape of the graph would be as shown in red on this slide. Okay. So please take note that when you draw your shape, it should match the nature table, and you should also check back with the original function, which is a cubic function, and the graph should look like a cubic function graph. Okay, and please label all your turning points, all your x-intercepts and y-intercepts as they exist clearly on your graph that you sketched.